In this lesson, we're going to be looking at degreed measured angles. Let's start by determining the quadrant in which each angle lies. So for example A, I'm going to draw a coordinate plane. I'll go ahead and get one ready for B. For question A, we want to determine the quadrant in which this angle lies. Now, you don't have to draw this coordinate plane if you don't want to, but it might assist you in getting the answer. So from reading section 5.1 and answering questions, we should know that the quadrants are labeled as 1, 2, 3, and 4. If we want to measure off an angle whose degreed measure is 87.9 degrees, then we're going to start on the positive x-axis. We'll call this our initial ray. And if we want a positive measured angle, then we're going to rotate counterclockwise. We should also know that we have a right angle here, so this degree measure would be 90 degrees up here. So 87.9 would land, I'm going to go ahead and draw a circle here, would land just short of all the way up to this positive y-axis. So we're in quadrant 1. All right, let's look at part B. What quadrant is this angle that has a degree measure of negative 8.5? Well, from our reading, we should know that we always start measuring angles from the positive x-axis. If we have a negative degreed measured angle, instead of going counterclockwise, we're going to go clockwise. Well, negative 8.5 degrees is just slightly below the positive x-axis. That's probably not a good representation. This is more than negative 8 degrees, but it at least accomplishes answering the question of what quadrant we're in. We're in quadrant 4. So again, you don't have to draw the coordinate plane if you can just look at the degreed measured angles and know what quadrant they fall in. Let's sketch each angle in standard position. So 270 degrees, I'm going to go ahead and draw a coordinate plane. Might want to go ahead and draw kind of a circle here. This is a positive measure, so we always start from the positive x-axis. We're going to go counterclockwise. We can use these different axes to help us count off. I know if I swing this ray up in this direction, I'll be at 90 degrees. Over here is another 90 degrees because of another right angle. So that's 180. And then if I add 90 more, I'm going to end up right here at the negative y-axis. So I'm going to darken that in. I'll put a little arrow on it. I'll come back and kind of connect these. This kind of shows the direction I'm going and where I'm going to land. So this is our initial ray, and this is our terminal ray right here. All right, negative 120 degrees. All right, go ahead and get a circle here. We're going to start here. We have a negative measure. So if we go negative 90, we land here. Now beyond negative 90, I need to go 30 more. So I think about this next quadrant right here as being 90 degrees. And if I need to go 30 degrees more to get to negative 120, I know that this total 90 degrees can be divided into 3 equal sections, each of which is 30 degrees. So I'm going to start here. This is negative 90. I'm going to pick up 30 more degrees, and I'm going to stop right here. Notice that I'm in quadrant 3. So let's darken the terminal ray and the initial ray. So you want to kind of be careful here. I don't want to show that I'm landing with this angle halfway between quadrant 3, because halfway between 0 and this 90 degrees is 45, and I don't need to quite go to 45 degrees to get to negative 120 degrees. Example C, negative 450. Well, I do know if I swing all the way around, that's negative 360 degrees, but I have to go more, and I have to go 90 degrees more from negative 360 degrees to get to negative 450. So this is negative 360, add 90 more, and you're going to land right here again on the negative y-axis. I think it's good before we go to D to look at the comparison between A and C. These are called, from our previous reading, these are called coterminal angles. They're coterminal angles because they start at the same place, positive x-axis, and they end up at the same location. The terminal rays fall at the same location. So these are coterminal angles, and notice that this is a positive measure and that's a negative measure. And the difference, as we might be reminded, between coterminal angles is some kind of multiple of 360 degrees. That is, let's kind of explore this relationship. If I looked at 270 degrees and I started subtracting 360 because I want a negative 450, the first time I subtracted 360, I'm going to get negative 90. So what that tells me is negative 90 degrees would also be another name for this angle right here that lands on the negative y-axis. Let's take negative 90 and subtract another 360. Well, by adding or subtracting multiples of 360, we can find coterminal angle measures. So we land at negative 450 degrees. So we verified with a calculator that we do have two coterminal angles. Let's go to D and let's sketch an angle whose measure is positive 600. Well, I know I'm going to go in the counterclockwise direction because that measures off positive angles. So I know I need to go at least one complete rotation. That's 360. Then I'm just going to start counting by 90s. So that's 360, 90 more up here would give me 450. 90 more would give me 540. Well, 540 plus this entire quadrant would give me 630. That's too much. So again, I'm at 360 plus 90 plus 90, I'm at 540. And I look at this number and I go, well, 600 minus 540 is 60 degrees. So I need to continue here 60 more degrees, which means that I'm not going to quite get down to the negative y-axis. 60 degrees is 2/3 of this quadrant. So if this entire quadrant is 90 degrees, this is 30, this is 60, and that's 90 more. So I'm actually going to stop right here, a little more than halfway through quadrant 3 to pick up that additional 60 degrees that I need. All right, let's pause for a moment and compare part B and part D together. Notice that these are coterminal angles. Again, their measures should differ by multiples of 360. So let me go back and just verify. Negative 120 degrees plus 360 gets me to 240. That would be another coterminal measure. But let me add another 360, no other number for coterminal. I do end up at 600 degrees. All right, for this next group of problems here, we're going to determine two coterminal angles in degree measure, one positive and one negative for each angle. You could draw a picture if you wanted to. You could draw this angle in standard position and use that picture to kind of help you understand what we're doing. If I were to draw an angle whose measure is 114 degrees, I know I'd have to go slightly beyond 90 degrees up here on the positive y-axis. If I took 114 and subtracted 90, I'd get 24 more degrees that I would have to travel into quadrant 2. So it would look something like that. So if I want two coterminal angles in degree measure for 114 degrees, I'm going to add 360 to go all the way completely around from this terminal ray. And then I'm also going to subtract 360 to go the other direction and to end up with this coterminal ray. So here's what I'm going to do to get two coterminal angles in degree measure, one positive and one negative. I'm going to say theta subscript 1, one of my answers, is equal to 114 degrees plus 360 degrees. So doing that computation, I get 474 degrees. So if I were to sketch an angle from standard position of 470 degrees, I'd have to go around 360 and 114 more. All right, let's see if we can find a coterminal angle for 114 degrees that has a negative measure. So I'm just using 2 to represent the second one I'm going to find. So instead of adding 360, let's take and go the other direction and subtract 360 degrees. And when we do that on our calculator, we get negative 246 degrees. Which if I were to sketch negative 246 degrees from standard position, I would have to start right here at the positive x-axis and sketch in a negative direction up to 246 degrees. I should land at the same place as my angle whose measure is 114 degrees. These subscripts just kind of, these 1 and these 2's right here, they just kind of help us keep track of all the different coterminal angles we're finding. Okay, look at B. Same objective. I do notice that an angle whose measure is negative 390 degrees is more than negative 360 degrees. So what I think I'm going to do first here, hopefully I'll get one coterminal angle, is I'm going to add 360 degrees. I'm trying to get into the positive numbers. But notice when you add these two, I don't get a positive measure, I get a negative measure. That's okay, because for my second coterminal angle, I'm going to take negative 30 degrees and add another 360, and that'll put me in the positive numbers. And when I do that, I get 330 degrees. So notice to accomplish part B, I had to actually add 360 degrees twice so that I get a negative and a positive measure. In part A, I added 360 and then subtracted 360 because of that number 114. Okay, if you're comfortable, turn off the video and then come back and join me and check your answers. I'm going to go ahead and start adding 360s here because I know when I add 360, I'll still get a negative measure. Now I'm going to take negative 85 and add another 360, and that'll put me in the positive numbers. Would it be okay to go ahead and subtract 360 from negative 445 degrees? Sure, that would just give us a negative coterminal angle, but to eventually get to a positive one, which we're being requested to find, I'd still have to add 360 degrees twice to get that one. I see 230 degrees. If I add 360, would give me a positive measure. And I see if I took 230 and subtracted 360, I'd get a negative measure. All right, so far we've determined quadrants in which angle lies. You can use a sketch to assist you. We've also been asked to sketch an angle in standard position, knowing we always start on the positive x-axis and then either go counterclockwise or clockwise, depending upon if we have a positive or a negative angle measure. And the next thing we looked at is determining two coterminal angles for a given angle by either adding or subtracting multiples of 360. All right, for this next part right here, we're asked to use the angle conversion capabilities of a graphing calculator to convert the angle measure to decimal degree form. Round your answer to 3 decimal places if necessary. All right, you might be looking at these two given angle measures and go, I've never seen that before, and likely you haven't. This presentation of these angles and these systems, the way they look right here, is different than what you've seen. You're used to seeing an angle measure given to us in decimal degree form, something like this. All right, I'm going to start with this example first. Just kind of explain what these symbols are right here. So consider an angle whose measure is negative 408 degrees. This is 16 minutes. So that one little mark there is a minute mark. And 25 seconds. So the double mark is the second. And what this is that this really gets to be, this breaks down a degree. So for example, this angle measure is more than negative 408 degrees, but it's less than negative 407 degrees. This just gives us a more specific amount of the degree measure. This is a breakdown of 1 degree. I know that's kind of weird, but this is often used in like navigation, boating, aviation, etc. So you've likely not seen this, but this is called the degree, minute, second format of an angle. Notice over here in this example, we have 64 degrees and 45 minutes. So this is not quite up to 65 degrees. And remember, there's 60 minutes in an hour, so to speak. So 45 minutes here is almost an entire minute. So we're closer to 65 degrees than we are 64 degrees. So I know it's a little strange, but all you have to kind of know is the calculator capabilities for what we're doing. All right, so let's change this, angle measure to the decimal degree form. So some new keystrokes. So let's enter -408, and we have to, for this conversion, we have to enter the little degree symbol. So you're going to find that in the angle menu, which is above the apps key. So notice we're going to hit second, apps, which is angle. And then right there, your first choice, press enter, we'll put a degree symbol. Then let's type in 16. We need minute mark. So again, go to the angle menu, second angle, go down to option 2. Okay, now we're going to enter 25 seconds. Well, you might have noticed that there is not a double, like a quotation mark there. We don't find it up here in this menu. So let me quit, but I still need to go to the end here and put the double quotes. So you can see down here above the enter key, okay, you see the plus key? To the right in green is the quotation marks, which represent the seconds. So we have to access the green. So now I'm just going to hit alpha plus, and that's going to put your seconds on that degree measure. And then once you have it entered, all you have to do is hit enter. Okay, now I have a decimal degree form. So this is -408 point. Read back here, it says round to 3 decimal places. So 0.274 if I'm rounding. And then don't forget to put your degrees on there. So this 0.274 degrees is actually represented in the minute second piece of this presentation of 16 minutes and 25 seconds. And think about 16 minutes out of 60 minutes. 16 minutes out of 60 minutes is about a quarter. It's about 1/4 of that entire minute. And 0.27 is a little more than a quarter, because a quarter is 0.25. So should make sense to us. Okay, before we go to the other example over here, I want to point out, some students often ask, does it matter what mode I'm in to convert like this? Well, let's go back and look at our mode key. I was actually in radian mode instead of degree mode. That's okay. Doesn't matter for what we're doing here, what mode we're in. For example, if I come down here and I change my mode, press enter, highlight degree, I go back, let me go back up and collect that. If I hit enter, it brings it back down. If I hit enter again, notice that it didn't matter if I was in radian or degree mode. It's just kind of common practice at this point for what we're doing, just to leave everything down the left column highlighted. We'll be messing with the mode key later, but for this objective, we don't need to. All right, so practice this one right here. We have no seconds, just minutes. I'm just going to press enter. So 64.75 degrees. 0.75 is about 3/4, and 45 minutes is about 3/4 of 60 minutes. All right, so now let's go the other way. Let's change what we're used to, something like this presentation, into this format right here. So what's -115.8 degrees going to be? Well, 0.8 is a little more than 0.5, so I'm thinking I should be more than 30 minutes. It should probably be closer to like 50 minutes or something like that. So let's see what happens. All right, let's convert this angled measure, this degree angle measure, to degree minute second. So same thing. I'm going to take -115.8. Now for this conversion, don't worry about putting the degree symbol on it. It's not necessary. Let's go back to second apps, and notice option 4 is to change arrow to degree, minute, second. So you don't need the degree symbol here. I wouldn't put it here. So I'm going to have negative 115 degrees, 48 minutes, and 0 seconds. And if you don't write down the 0 seconds, that's fine because there's not any there. So 48 minutes out of 60 minutes is definitely more than half, and 0.8 is definitely more than 0.5, which is a half of a whole. Alrighty, so hopefully you understand where those keystrokes are. Let's look at the next thing we're asked to do. Find the difference of the angles. Write your answer in degree, minute, second form. So if you're comfortable with what you're going to do, pause the video, and then in a few minutes turn it back on, kind of fast forward to see if our answers match. Remember, it's green, and then the plus key for the quotation marks. I'm not sure if we need parentheses here or not. I don't think we do, so I'm just going to go ahead and straight away enter this angle measure. All right, I'm not going to record that because they're asking me to write my answer in degree, minute, second form. So what do? I'm just going to go up to my answer, pull it down, and I'm going to go back to the second angle key, go to option 4, and change that. Right, well, it looks like we're going to get a negative measure here, and that makes sense because 36 degrees is definitely smaller than 81 degrees, so our answer should be negative. You might want to go through and check that one, but that's the answer I got for that problem. All right, last objective in this lesson. Let's find, if possible, the complement and supplement of the given angle. All right, so just to remind ourselves from our reading, we know that complementary angles are two angles, or two positive angles. So two positive angles that equal 90 degrees. They sum to 90 degrees. We also know that supplement would be two positive angles, that's an angle symbol, that equal 180 degrees. So complement 90, supplement 180. All right, so let's say we have an angle whose measure is 87 degrees. I mean, real quickly, to eyeball that, we would be about right, I'll get a little circle here, about right here, just shy of 90 degrees. All right, so to find the complementary angle, I'm going to take 90 degrees, and I'm going to subtract the given angle of 87 degrees. The result is the positive measure of 3 degrees. So a 3-degree measured angle and an 87-degree measured angle would sum to 90. We're good to go. Supplement, remember, is 180. Subtract the given angle. I think that's going to be 93 degrees. That makes sense. Because if I have 87 degrees, I would have to take all of 90 plus that 3 that's missing here, and that would get me down to 180, which is the straight angle right here. All right, look at 101 degrees. Does it have a complement? No. If we think about what 101 degrees looks like, it's actually going to be a little bit past 90 over into quadrant 2, so it's probably about right here. Okay, so let's just look at our math to see what we're going to find to answer correctly. So complement means 90 degrees. Let's subtract the given measure, 101. We can clearly see that we're going to get negative 11 degrees. Negative 11 is not a positive angle. So if you ever have a negative answer when you do the subtraction, then we're going to respond and say none. We're already past 90 degrees with just this one angle. So 101 degrees cannot have a complement because it takes 2 to add to the total 90. Now I'm definitely going to have a supplement because 101 degrees is not quite up to 180. Supplement 180 degrees minus the given angle. I think that's 79. This is negative. I can't have a negative measured angle in the complementary question, nor supplementary either, but this one does have a supplement. Okay, so our final objectives were to convert from degree minute second to degree form, decimal degree form, and then also go the other direction. And then just a little more practicing here with the keystrokes, the new keystrokes that we've learned, and then also revisiting what it means to be complementary and supplementary of angles.